So let us move on to the next presentation. Now, Dr. Marcela Angulo, voy a cambiar a, I'm going to switch to Spanish, Dr. Fat.
That's fine, thank you.
You are very welcome. Vamos entonces a pasar a la siguiente presentación.
We'll move on now to the next presentation, which is from Dr. Marcela Angulo, and she now is the director of the Concepcion campus of the University of Santiago. She's a civil engineer and the director in environmental sciences from the University of Concepcion, over 25 years of experience in matters of sustainability. And as I said, she's also the director of the campus in Santiago of the University of Concepcion, works in the Center of Research in Lota Arauco, environmental sectors, and was manager of capabilities, of electrical capabilities for Corfo, corporate manager of sustainability for Anglo American, and manager in environment and energy from the Chile Foundation. We will see a very interesting presentation from Dr. Marcela Angulo and the opportunity of the technologies for the use of green hydrogen in industries. So Marcela, please go ahead. Thank you so much, Patricio. And thank you for the invitation and for the opportunity of sharing a few reflections on the use of green hydrogen in industries and on large emitters, and not just for a bit of a complementary look with a purely electrical, looking at the production of fuel and energy, we're looking at a bit of a complementary view. I want to confirm that my screen is shown well. Yes, perfectly. Why did I want to show this perspective of opportunities for the use of green hydrogen with a few industrial processes, both associated to direct and indirect sectors, because the industry sector represents 33% of global emissions of greenhouse effect gases, and that is 21% due to direct emissions, and the other 11% is direct emissions with the consumption of electric consumption. So there is a relevant movement in the world in matters of large emitters on how to carbonization effort, seeing the carbon footprint with large efforts in electrification, and as said in the previous panel, and when it's impossible to do electrification, there's a relevant role. Hydrogen has a relevant role in processes, industrial processes, as part of prime matter in industrial processes. So I wanted to bring a few examples, a few restrictions in terms of what's happening in the cement industry or the steel industry, in order to conclude how these trends can also apply to the copper mine industry, which obviously is very important and relevant for Chile. So we know that there is a consensus in terms of emergency of climate action. We're not complying with the reduction goals, so we need to accelerate this target in order to ensure that we do not generate a further increases in temperature that will have irreversible impact in our planet. So the first thing that I would like to comment is what the cement industry is doing so far. It represents an 8% of gas emissions at the worldwide level. There's a high demand and high temperatures required for the production, for the productive processes. So the options that the cement industry has committed with have been quite important and have to do with the substitution of fuel and capturing carbon to use it along with green hydrogen and produce derivative green fuel. So a few things that I'm thinking about are different plants in the world. One of the plants in the UK has a pilot project using mixes for green hydrogen to substitute the process used in the productive process. So we have a concrete example here, and I'm showing you that the cement industry has also had roots to have a low carbon energy moving in the same direction. So there are possibilities that these things will arrive well to Chile. So the second case that I want to show is the steel industry. The steel industry is also one of the large emitters. Represents about 8% of emissions, and I wanted to share here an initiative. We have substantial progress in matters of emission, both in Germany and Sweden. I wanted to bring the Swedish example because it's an ambitious initiative. Even though Sweden is not such a relevant iron producer, they do have a very interesting plan to lead energy. And this is a project that's called Hybrid. It's an alliance between three large players of this sector. On one side, we have an iron producer, a public company, and Battlefall and the utility company with the water and energy, and finally SAP, which is iron product. So this is a very complex product with several components, 6 research and development projects, large pilot plants that obtained a subsidy of the Swedish government. It's the largest subsidy in the history of the country and has the purpose of producing 2 great changes using green hydrogen. One in production of iron, the iron ore mineral, and the second is the production of metallic iron through technology of direct iron reduction technology, substituting the carbon used traditionally as reductor agency by green hydrogen. And here we see a projection that this could in fact be a very ambitious initiative that might have 10 gigawatts of electrolysis renewable, almost by a fourth of the goals used by the European Union. And this is one of the projections that we aim to be successful in. It's being developed in right now. And from these 2 first examples, I want to drill into copper mining, which is what interests us in Chile, commenting that climate change and an energy tension that is going to have a direct relationship with mining, because mining is going to supply some of the metals that are key for this. And we're talking copper, lithium, iron, and obviously these metals won't be able to be produced in the same way. And to provide minerals for the decarbonation, mining will have to transform as well. And so I brought here a few examples of how they will have a traceability for the carbon footprint. And we're considering the copper market for sustainable representation of copper. And what we expect is, as this will grow in time, because this is a very recent analysis of copper being the new fuel, new petrol, and there's no decarbonization possible without copper. And this draws projection on the demand on copper and for the industry of electromobility and the renewable energy industries where copper is an alternative fuel. So how does this demand need to transform or reach our own industry and with a broad side of how can green hydrogen be used for decarbonization processes. First of all, on the scope 1 that we have for direct emissions for mobile and As we commented, we have mining fleets with green hydrogen or synthetic fuels, and fundamentally processes that may use green hydrogen in electric energy, of course, renewable energies. Um, then the third scope with the production of materials that can use green hydrogen in their processes for production of ammonia, uh, hydrogen peroxide, and others. So I wanted to briefly mention this. Victor's going to mention it later. I believe Patricio did as well. In matters of mining mobility, Chile is making a few efforts. There are many things happening around the world as well, but we have 3 initiatives in Chile for dual combustion, diesel, and also motors and engines, and consortiums that are supported by Corfo and the innovation agencies in Chile. But I want to also bring a few perspectives on how these same technologies used in the iron industry, for example, can be used in copper mining. So in general, as we know, mining processing has a line of hydrometallurgic, and we're running out of oxides in Chile. So by 2030, and total production is going to be copper concentrates via sulfurs. And we have 2 options. So either we process in Chile or we ship it and we export it for the concentrates for it to be processed in China or elsewhere. So the matter here, important matter here, is that we have the opportunity, we have a problem and an opportunity, and traditional metallurgy still has, even despite evolving, has a lot of problems in matters of carbon emissions, CO2 emissions, arsenic, which is something that we have naturally in mineral percentages in Chile. And this generates a large amount of lost material and materials that are present in the copper concentrate. So we just take the concentrate and we dispose of all the rest. And that, of course, is something that is not sustainable on the long term. And where are all the possibilities? Here I have two looks for 2 different technologies, looking at what the Swedish are doing, or what the cement industry is doing. And it's perfectly possible with the same logic to use green hydrogen as a reduction agent in order to reduce the slags that are still in a melted phase before they solidify. And with this carbonates and silices, we can then introduce 2 massive products of high consumption as radium that's used today in the steel industry, cement or cement additives. This is a technology that right now is developed by the University of Concepcion, is in treatment phase, and has all the patent requesting processes on the way. And these are some of the ways that we can use green hydrogen in an extensive way. And another possibility is a technology also developed by our university that is in advanced treatment phase, in level 5 of technological maturity, with a disruptive outlook, a new paradigm of how to process concentrates that resembles what's being done in the steel industry. Fundamentally means to substitute the traditional melting and then the processes of fusion and oxidation and reduction with the reduction with green hydrogen. In this case, what this technology proposes is on one side to be able to operate in solid and gas phases in closed reactors that do not use the liquid phases, so you avoid some of the problems, and also has several environmental advantages because this would allow high levels of recuperation and recovery, and would prevent the generation of slags, because it would allow us to recover all the copper, all the iron, all the silica concentrates, and that has a commercial value. We can recover all the molybdenum that's recovered from the concentrate. So we have a more of a disruptive outlook. These are technologies that is being developed and would allow us to show more of a circular economy in copper. When a plant of this magnitude could be placed near mining sites, and here we have mining mining with a capacity of electricity that's very large, but this plant could be even larger and generate hydrogen for other mining resources, such as the case of mining mobility, production, and storage, for example. So I will wrap up by commenting some of what's the outlook of possibilities of use for these large emitters, or universities also working on the case of the Biobío region, where we are seeing a potential third pole of production, such as the Atacama Desert and the Mayagans region. In the Biobío region, we have an outlook in points of making a third pole oriented to domestic consumption, because there is a clear convergence in industrial ports that generally are located in industrial poles of heavy industry. And in the case of Biobío, we have ports, we have oil, we have metal, chemical, paper industries. We have lots of industry poles associated to these industries. So we considered a collaborative process of the Green Hydrogen Alliance for the Biobío region. That's a project, that's the initial project, 1.5 years, when we are mapping the opportunities and the analysis of business cases, and building the trust, being the networks to move on to next phases. In this effort, we're not only achieving and managing to attract universities in the region, but also the important group of companies that are participating. There's about 15 companies here that are participating in AP, NDC, Siemens Biobío, CAP, other large companies and medium companies that are also interested in participating in this. And what we are seeing is how to promote the possibility of generating collaborative projects with multi-actors. So this concept of hydrogen valleys in the short and the short term, the medium term. And we have a concrete case, which is in the industrial pole of Talcahuano, which is a territory of less than 3 kilometers, or at least 5 kilometers, to be a bit fairer. And we have the ENAP oil refining plant. We have the Huachipato plant. They have a petrochemical pole and several ports. So here we are seeing a possibility for constituting a project that could have carbon capture, green hydrogen production, use of green hydrogen in industrial and mobility processes, but also production of methanol and derivatives that could be of interest for the chemical industry. I will wrap this up now, and I want to thank you all for the possibility of sharing this with you.
Muchas gracias, doctor Angulo. La verdad que muy impresionante lo que se está haciendo.
Thank you so much, Dr. Angulo. It's very interesting what you're doing and what the Concepcion Polo is doing. It's very promising, and thank you so much for sharing and for your presentation. We'll leave a few questions for the end to continue with the agenda. So we will continue with the Q&A session. I will introduce now. Thank you so much, Dr. Angulo.